Welcome everybody to the Accidental DBA. This is a tutorial for everybody in the room who has found themselves in charge of one or more PostgreSQL instances without ever having any real formal training on how to manage those. So the goal of this tutorial is to let you know enough that you know what you don't know and what you need to look up. And you know some of the basics about administering Postgres. So that's what this is for. So what we're going to cover here, we're going to cover installation, extensions, updates and upgrades, configuration, basic replication, connection security, backups, vacuum and query management, session management. We're not going to cover stuff like we're not going to cover the fact that the video cable is loose. We're not going to cover stuff like older versions of Postgres. If any of you have to run like 9.0 or an expired version like 8.4, can't help you because a lot of the administrative tools have changed over the last 5 years. We're not going to cover things like schema design. We can't go into query rewriting. I actually do a query writing tutorial, and that's 3.5 hours by itself. Indexes, testing, and we're not going to go into application stuff because chances are, you know, we've got like 5 or 6 different application stacks represented in this room. So already sent you instructions on all of the exercises and that sort of thing. These exercises are open source. They're on GitHub. So if you miss something during the tutorial, you can go back and do this self-paced, which is always nice because it's hard to get everything in the first try. So anyway, the reason why I put together this tutorial, which I put together first for DjangoCon like 4 years ago, was that an awful lot of people have had their boss say something like this to them. How many of you ended up in charge of Postgres this way? Like, you know Linux or you know Python or whatever, you know, you're in charge of our Postgres server. By the way, how many of you are primarily application developers? Okay, awesome. And how many of you are primarily system administrators? Okay, and how many people are titled sort of DBA? Oh, awesome, okay. So you guys, so for people who are titled DBA, are you primarily experienced with a different database system? Yeah, okay, so you're crossing over from a different database system. So yeah, so we've got all these other sort of reasons, right? You know MySQL, so you're in charge of Postgres also now, right? So you go, hey, you know, there's a lot of reasons why people do this. They're saying, oh, we're doing efficiency, we're staying lean, we're a new DevOps thing where everybody does everything, or it's all in the cloud and it doesn't require dedicated management, or hey, it's a huge growth opportunity for you. But really this is what this means, right? We're not going to hire a Postgres DBA. So somebody else needs to pinch hit. And if you're in this room, that's probably you. You know, it's a whole bunch of reasons. So you go through there and you say, okay, well, you know, Postgres has plenty of documentation. People say good things about the documentation. So actually go kind of through the primary documentation of Postgres, go to PostgreSQL.org, look at the docs and sort of thing. You go, oh, wait a minute, there's 6,000 pages of documentation here. Oh. I'm not feeling so good about this anymore. Fortunately, that 6,000 pages of documentation is mostly reference documentation for particular commands and particular configuration settings, etc. I will tell you that as somebody who has been working on the Postgres project for 17 years now, I will still run across things and say, wait, that's in the documentation? And periodically with people contributing to docs, you know, marking out stuff that, hey, that should have been removed from the documentation years ago because we don't support that anymore. So most of that you don't actually need to know. There are parts of our documentation that you will never access even if you administer Postgres for 10 years because those particular features are just not relevant to you. So Postgres doesn't have to be a big, angry, dangerous elephant. We can be a cute, fuzzy baby elephant. And you just have to know a little bit to transform one into the other. So let's go over that little bit. So Docker comes up really fast, so it's less important to actually do that right now. But it is, for the people who are doing Vagrant, you should go ahead and do Vagrant up now, because Vagrant takes a little while to come up. And I'm going to be talking a little bit, and that'll give time for Vagrant to come up. So first of all, I'm going to go back and go through installation. Now, we're not going to actually do installation, because I don't like to do that as a hands-on exercise, because if you have trouble with it, then you're kind of stuck for the whole rest of the hands-on exercises. But let's actually talk a little bit about how you should install Postgres. So the first thing is, and I'm surprised a lot of people don't know this, but if you are on Linux in the server environment, then just use the available packages, right? We have good up-to-date packages for, and there's actually two courses here, right? Number one, if you don't care about which version you're using because you're using Postgres in a very light way, you don't have requirements for particular libraries or whatever, then use the version that came with your distro, right? Red Hat 7 is shipping with 9.3, I think. Red Hat's, well, so the problem is you don't want to do that with Red Hat 6, because Red Hat 6, I believe, shipped with 8.4, something like that, maybe 9.0. You know, and CentOS, you know, current Debian and Ubuntu is a much more current version of PostgreSQL. SUSE, I'm not sure what version current SUSE ships with. But if you don't really care, like if you're using Postgres to store a cache or a queue table or whatever, you really don't care about what version of Postgres you're running, just use the one that came with your distro. However, for a lot of you, because you're using current PostGIS, because you have other requirements, because you want to do cool stuff with Postgres, you need a current version. And in that case, the PostgreSQL project maintains its own alternate repos for the popular flavors of Linux. So for Red Hat, CentOS, all the Red Hat stuff, we've got yum.postgresql.org. For Debian and Ubuntu, we have apt.postgresql.org. SUSE is the build service. I'm not quite sure how well maintained that is right now for Postgres distros. But we have those alternate packages. So what you do is you go through the different processes to add that repository to your server, and then go ahead and install PostgreSQL and its tools from there. The other nice thing about these repositories is they have a lot of PostgreSQL tool packages and extensions and other things that you won't find in your main repo packages. If you're on Windows or Mac OS X, the general perspective is to use the Enterprise DB installer if you want to install it on the system. The Enterprise DB installer is this graphical GUI thing and that sort of thing. Also installs pgadmin, some extensions that, you know, in those. There are a few other options for Mac, such as Postgres.app. But that has less stuff. It's a much more native Mac experience, but it's less stuff. Mostly these days, if you're going to be doing Postgres stuff on another platform, I recommend doing what you're doing for these exercises, which is running it in Docker. Because if you're deploying to Linux on the server, then you actually want it to behave in a much more similar way. There are other platforms that we support. Anybody here running a Solaris variant in production? No. OK. We do have packages for that. Stuff for free for the BSDs. You know, other platforms, you're pretty much compiling Postgres. Believe it or not, somebody actually has compiled Postgres for Android tablets. They did it more as an experiment than anything else, but you can do it. But pretty much, you know, most people are going to be using Linux on the server. So let's go ahead and log in to our virtual sessions. So in the case of Vagrant, you're going to do Vagrant SSH. In the case of Docker, you will already be logged in when you do the Docker run, so you don't need to do any further instructions. The one thing that that everybody wants to do, whether you're doing Docker or Vagrant SSH, is this thing called tmux. tmux is a terminal multiplexer, that's what it's short for, that gives you several virtual terminals. And we're going to need that during the exercises because we're going to be switching between different user sessions during the exercises. And so we actually want to switch between different virtual terminals. So for the Vagrant people, do these two instructions. For the people running Docker, just do tmux. And this is also on your handout in terms of the instructions. By the way, for anybody who came in late, there's a handout right up here that has instructions, right here on the end of the table. That has all the exercises. The actually, if we run out, then try to share. No, we didn't run out. Good. Okay. So, next thing we're going to do, so like I said, I'm not actually going to have you install Postgres here because I don't want to have a hands-on exercise that could block all other hands-on exercises if it doesn't work for you. But if you actually look at so this is the Vagrant VM or the Docker container is in Ubuntu. In the case of Vagrant, in Ubuntu 12.04 VM. In the case of Docker, in Ubuntu 14.04 container that has been set up, and it's already been set up with the Postgres repository. Now, the way that you do that in Debian, et cetera, is that you actually add this file under the apt configuration as root, you know, add a sources file pgdg list. The easier way to do that is well, I'll show you that in a minute. So it looks like it's going to take a while to come up. Oh, wait, no, there we go. The easier way to do that is if you go to app.postgresql.org, there is a shell script linked from there that if you run it as root will install all of the configuration and the encryption key and that sort of thing required to have the extra Postgres app repository. In the case of Red Hat, you go to yum.postgresql.org, and that will provide you with a set of links. And the links will eventually drill down to an RPM for your version of Red Hat or Fedora or CentOS that installs the extra repositories. And if you actually look at, let's scroll that, hey? If you actually look at the list of stuff that's available from our repositories, you discover there's a whole bunch of extra tools and that sort of thing, a couple of which we will be using today. A lot more of which are going to end up being relevant for your particular application stack. So, after you've installed Postgres, the second thing that you may or may not need to do is create what's known as a data directory. So the idea behind a data directory is, what defines a Postgres instance is that you have a directory that, or a set of directories that contain the PostgreSQL configuration and all of its data files, and certain other things like the control file and a PID file and that sort of thing under this data directory, and that defines the Postgres instance. And that's where all of your data files are. Now, most of your package installs, if you install, the Linux packages, if you install the Enterprise DB installer, it's going to install that create a data directory for you in a default location. The thing is, when you're actually doing this in production, you may not want the data directory in that default location. You may want it somewhere else, like you may want it on a particular partition that's on faster disks, for example. You may want it on the SAN or somewhere else that's going to be a specific location. Or you may want to run more than one Postgres instance on a particular machine, which requires creating more than one data directory. You can run as many Postgres instances on a machine as you have processing power available. And each instance is defined by creating its own data directory. And the tool that the command that you use to create this is called initdb. So let's actually do that. Now first, you're going to switch to the Postgres user. You see the command there, which is going to be, I've already set this up because I actually wanted to set up the terminal environment, so I'm not actually going to run this. I'm just going to switch off to the Postgres user right here. So we're going to just create a test directory. And that's pretty much it if you have the rest of your environment set up. So just do this initdb test, and it'll go through this whole long series of all of these things that it is creating. And it actually even gives you some helpful instructions in the end if you want to start Postgres. Now again, in a production environment, you're actually probably going to want to create an operating system, a init script or systemd configuration or Windows service definition in order to have the operating system automatically start Postgres. But when you're testing, et cetera, or when you're doing it in environments like containers, these commands actually work pretty well, and we'll be going over those more in a minute. But for right now, let's actually look at what's in that data directory. So if you look in the data directory, we've got a whole set of different files here. And actually, if we actually go, so in the base subdirectory, for example, you see a bunch of numbered directories. And these numbered directories actually are the databases. So when you install Postgres to begin with, you actually get three databases right off. You get the special template 0 directory, which is the template for all other databases. You get the template 1 database, which is a customizable template database. And you get the Postgres database, which is a sort of scratch database that comes built in. And if you actually look in the system files, you'll see that these numbers are the IDs of those, which is how it all maps. And you got a whole bunch of other things. It's not important that we look at these really closely right now. We'll be working with some of these files later on. One of the other important things to know is you don't casually delete anything from this data directory. There's a lot of files in here that if you delete them, Postgres will not function, and it may not be recoverable. Particularly those two directories called PG_CLOG and PG_XLOG. If you delete those directories, it will not, you might as well, it's time to go immediately to the backup. Because, well, there's still data there, you can't really read it. So, now, one of the concepts that I actually need to explain here for this, because it's a little confusing for people, is the concept of superuser. That is, you'll see a lot of stuff in the documentation, a lot of people referencing it, they're talking about the superuser. And the superuser is the user that has control of, that has absolute control over the Postgres instance. Now, unfortunately, the word is actually used for two slightly different kinds of users who are generally the same person, but not always. So like in a default package install on Red Hat or Debian, you're going to get a user named Postgres, Postgres. And that user named Postgres will be the operating system owner of all of the files in the data directory. And it will also be created inside the database with a special superuser permission. However, inside the database, you can actually grant that superuser permission to other users who don't own the database files. So there's actually kind of two classes of superuser, which is one of the things that confuses people. Also, the other thing people confuses people is you hear the term superuser in terms of the operating system, right, where the superuser in Linux is root. So Postgres has its own superuser. And by the way, that superuser can't be root unless you want to hack Postgres to make that happen. because there are a lot of security problems with having Postgres run under the root user, and therefore the Postgres code will prevent you from starting a Postgres instance that is owned by the root user. And you'll get a specific error message saying Postgres may not be run as root. On Windows, Postgres may not be run as sysadmin. And so if you get that, that's why. You need to actually have a different user that is not the operating system superuser. The other important thing to know about superusers is if somebody is granted the superuser permission, they can do anything, including writes and reads directly from the PG data file system. So somebody who has superuser permissions cannot be meaningfully restricted in any way. And for that reason, you don't want your application connecting to the database as a database superuser. Oh wait, we already did that. So having actually initialized a directory, I'm going to go over a little bit of the different ways of starting and stopping Postgres. So there's 3 different ways to start and stop Postgres on Linux, and one of these applies to Windows as well. But on Linux, by the way, so actually let me get a quick hand. How many people here are using something other than Linux on the server in production? Ah, there we go. What are you using? Oh, OK, well this is not going to be different in FreeBSD. So so first is your various service and initbd scripts, systemd config, systemd jobs, anything else. The operating system service definitions. And in general, this is the way that you want to start and stop Postgres, right? It's a database. You want it to come up when the operating system comes up, and therefore you want to start and stop Postgres that way. Where that would be different is on your laptop, right? If you've got a copy of Postgres on your laptop for development purposes, you don't necessarily want it to be running all the time, because Postgres does a lot of CPU polling, and therefore it consumes a lot of power. The second thing is we provide a utility called PG_CTL, Postgres control, which we copied that idea from Apache HTTP. This is pretty good for development and testing. Like say you're going to have an automated test where you're going to spin up Postgres, run a bunch of tests, and then shut it down. PG control is great for that. It needs to be run as the superuser who owns the files. So that first class of database superuser, which means on most installations the system user Postgres needs to run that. Can't be run again as root. If you try to run it as root or as system admin on Windows, you will get an error message saying can't be run under this user. Then the third thing is the actual executable when you're starting up a Postgres server is a executable called, appropriately enough, Postgres. And most of the time that's not going to be relevant to you. You're going to want to call either a service script or PG control that wrap Postgres because they do a bunch of other things. However, if you are writing in a init script, or you are writing a Docker container definition, or you are writing another system that is going to start Postgres, as you're writing that wrapper, then you actually want to call Postgres. Because among other things, things like PG control in the service have indirection. They actually start up other processes. And so it can be sometimes challenging to get a response from them if there's a problem starting up. Whereas the Postgres command will give you any error messages directly to the calling process. The thing that you shouldn't do as part of stopping Postgres is kill. If you're using kill to shut down Postgres, that should only be because things have already gone horribly, horribly wrong, and the system is in a bad state anyway. Particularly kill -9, which for Linux geeks, that is kill with extreme prejudice, is a bad idea on Postgres backends. If it's a stuck query, where one process is consuming a lot of resources and you can't shut it down by normal means, and you do a kill -9, that may cause all of Postgres to shut down because it'll have blocks of memory it has lost track of, and then Postgres will shut down unexpectedly. And also, we do a lot to make Postgres crash safe. but there's no reason to invite trouble. And if you're doing a kill on Postgres, you're basically forcing it to crash rather than to do a clean shutdown. If nothing else, even if everything goes perfectly, when Postgres comes up, that means it's going to go through crash recovery. And it can, if you have a large database with a high level of activity, going through crash recovery can take minutes. And in extreme cases, with a large database and slow storage, hours. So you really don't want to use kill as your way of normally stopping Postgres. So when we're starting and stopping Postgres, we've got 4 states that we're going to talk about. Start, stop, restart, and reload. So start and stop are actually pretty obvious. It's, you know, kind of what it says on the tin, except for Postgres stop, we actually provide 3 different modes of stop. So mode number 1 is what we call smart stop, which is a euphemism because it's actually dumb stop. Because it says, wait for all users to exit, don't allow any new users to log in, and wait for all users to exit, and when the last user is exited, shut down. This seemed like a lot smarter plan back in 1999 when the database might have like 3 active connections and when people were sort of interacting directly. Today, when you've got applications and connection pools and stuff that are always continuously connected to the database, smart stop is pretty useless, but it's important to know about because unfortunately it's the default for historical reasons. Fast stop says, kick all the users off, but send them a normal termination message. You know, send them a your session's been terminated message. Kick them all off, then shut down. Then the final one is immediate stop. And immediate stop is kind of like sending a kill. The reason why you do immediate stop is the data center has just lost power. You have about, 5 minutes to, 5 minutes to log in through the lights out management and try to shut the system down cleanly before it loses power. And that would be a reason to do a shutdown immediate. There's not really another reason to do a stop immediate. Otherwise, you always want stop fast. Yeah?
Do you get any safety from using immediate stop rather than just running kill?
Not a lot, no. The only thing that immediate stop does that kill doesn't is that it actually kills the processes in the correct order. So it makes sure to kill all the backends before it kills the postmaster. Because, once we start running Postgres, you'll see it runs a lot of processes.
So does fast, disconnect people, then try to do an orderly shutdown quickly?
Yes. Yes, correct.
They said you've got 1 minute to stop this. Would you try it fast first? Or?
Someone would have to write a script for that. Okay. I don't know one, yeah?
So what's the default when you do service Postgres?
Right, so service Postgres, if you're using any of the packages that come from the PostgreSQL project, they do fast. If you're on an older system running an older version of Postgres with OS-specific packages, it may be doing smart shutdown. So particularly if you do service Postgres stop and it just never it never stops, it may be because somebody implemented the script doing smart shutdown, and then the answer is to fix that in the script. So restart. So restart shuts down and restarts Postgres. It's going to break all connections to the database. Reasons why you do this, you need to change one of the Postgres settings that, you need to change one or more of the Postgres settings that requires a restart to change. Like the amount of dedicated memory allocated to Postgres can only be changed with a restart. The number of connections you support can only be changed with a restart. We'll go over some of these specifically. But there are things that actually require a restart to change them. The other reason, and for that matter, archive mode, if you want to enable or disable transaction log archiving, sort of the naive way, then you have to restart it, and there's other settings. And I'll actually show you a way around that. So those are the reasons why you'd want to do a restart. Thing is, most of the time you don't actually want to do a restart because people are using this database and it's disruptive to the application to have a whole bunch of disconnect messages, right? So what you want to do most of the time is a reload. And a reload simply tells Postgres, hey, reread all of your configuration files and flush the system object cache on the various backends and that sort of thing. It will read minor configuration changes. It doesn't break any connections. This is one of the things you do. You want to change logging. You want to change where archives are going to. You want to change defaults for some things. Then you can just do a reload. Also, it's important to know that in a reload, if you change one of the parameters that is a default, that only affects new sessions because we're not breaking the session. But so reload is what you're going to do more of the time than anything else. So let's actually do this. So again, going back to your sheet. So we should be root currently. If you are still in here as Postgres, then type exit to get back out to the root shell. So we're going to start Postgres. Restart. That's pretty simple. Service commands are meant to be simple. Now we actually get a little bit more complicated if you actually want to switch over to the Postgres user. So again, you'll type su Postgres here. I'm actually going to switch over to a different window. And so now I'm going to do the PGcontrol command. So PGcontrol requires a -d, -D parameter, which tells it where the data directory is you're starting up. Now, you can actually define this as a shell variable. That is, if you define that shell variable, then you don't need the -d. And so for some custom setups, what people do is they actually define the shell variables for PGUser, for PGPassword, for a bunch of other things. So a lot of people writing automated scripts will actually set those up in the user's environment instead of sending parameters. But we're going to send parameters right now. Then we're going to tell it where the directory is that we're starting up. Now, one of the things that Ubuntu does that's different from the Red Hat variants and other systems that I actually quite like, which is one of the reasons why we actually do this in Ubuntu, is Ubuntu separates the configuration files from the actual data files and puts them in a different directory. And that's actually really kind of nice because often the configuration files are going to be under like management by Puppet or Chef or something. Sometimes if you've got multiple Postgres instances on a machine, you might want to share some of the configuration files between multiple instances. And in a high security environment, you may want to lock down the configuration files because the Postgres user needs to be able to read the configuration files, but it doesn't need to be able to write them. And so if you want to restrict the permissions of the Postgres system user for security reasons, then it's nice to have the configuration files somewhere you lock them down. And so I really like this from Ubuntu. But if you're on a Red Hat variant, if you're on Windows with the Enterprise DB installer, if you're on Mac with the Enterprise DB installer, then your configuration files are going to be located in the Postgres data directory. The reason why that's important is when you do a start, the actual -d you give Postgres is not where the data is located, but where the configuration files are located. Because one of the things you can have in those configuration files is where is the data located. But you can't go the other way around. So that's why we're pointing this to etc. PostgreSQL 9.4 main, which is where the configuration files are located.
So what would be the best practice to emulate the Ubuntu separation of configuration files on the Red Hat variant?
Well, if you want to do that, you could just create in etc. PostgreSQL a version instance, a directory in etc. And then you would need to modify or replace the init scripts, because the init scripts expect stuff to be in the PG data directory. So go ahead and do that. And so then we get slightly different feedback here, right? Is we're doing this, and we're redirecting log and that sort of thing. This is because I've already configured Postgres, and I'll show you this. I've already configured Postgres to log to a directory under var log. If you haven't configured Postgres to log to a directory under var log, this process calling PGcontrol will get all of Postgres' log output, which is not something you necessarily want except maybe in a container environment. So Postgres has been started there. And then here's where you actually see the modes, right? So the modes are switched. And that -m is for mode. So by the way, the exercise handout is right up here, if you want to grab it. Okay. So there we are. We're going to stop it. So now let's actually look at some of the things that can happen when Postgres starts up in terms of figuring out what's going on and what's going wrong. Because this is actually one of the big issues that sort of new DBAs have. So go ahead and exit the Postgres shell here. We're going to switch back to the root shell. But I'm actually going to switch right over here. So we're going to go to that configuration directory. And you can see here's the configuration files. And right now we're going to make a small change. Now, here's an important thing. I've installed a bunch of different command line editors in these containers or VMs. What should be available is VI, VIM, Nano, and then a small text editor called Joe that can simulate several other text editors. So you can just use it straight up as Joe, or you can use JMax, which is a sort of lightweight version of Emacs. So whatever you're comfortable with. If you're not really used to Unix command line editors, I suggest Nano as being the simplest one. So here what we're going to do here is simple. So we're going to add a bogus configuration parameter that's not a valid configuration parameter here. And just put it at the top of the file, and then save it. Now, one of the things that you'll run into when you're actually administering Postgres in production is that Postgres will refuse to start for various reasons. And some service scripts, like the current ones in Ubuntu Trusty, are good about giving you back error messages on a failure. But some of them are not, particularly the rel ones and stuff. It'll just tell you fail. It won't tell you anything else. And so if it just tells you fail and it doesn't tell you anything else, then what you actually want to do is you're going to need to look at the logs. Now, I've configured this to have particular logs. So a couple of these logs are created under different circumstances. So this one is the default location for the log under the configuration file. And then I reconfigured the logs to use weekly rotation. So that's not actually giving us that. So the other one, and you have to actually look at both because this is a startup log. The default configured one is the startup log, and here we've actually got our error message. Yes?
I have a question about PG control. Is there a difference between PG control and PG cluster control?
PG cluster control is a wrapper around PG control that ships with Debian and Ubuntu. And the goal is to provide a controller which can handle having multiple versions and multiple PG data directories, multiple instances running on the system at once. And it has some nice features, but because it is specific to Debian and Ubuntu, I'm not going over it during this tutorial. But PG control cluster will take the same switches that PG control does at the end. You have to say PG control cluster version instance, so like 9.4 main, and then it'll take other switches.
Okay.
So you have to actually look at that, and then, so we actually want to edit that, and, right, I have to go back to where I was. Go ahead and edit the configuration file, remove the bogus parameter, save it. And now we should be able to start Postgres. So, like I said, if Postgres fails to start, in most of your configurations, there's actually going to be 2 logs like we had. So here we have, this one is actually created by the Ubuntu service, and that's the startup log. And this one is the one that's configured in the PostgreSQL configuration. And if Postgres fails to start, you're going to have to look at both of them, because if there's a problem with the configuration, then it's going to be in the startup log. If there's a problem almost anywhere else, then it's going to be in the configured log file, right? Like if you have data corruption and Postgres won't start for that reason, that's going to be in the configured log file because it'll switch over before it discovers the data corruption. Mm-hmm.
So if you make any changes in the postgres.com and then if I do the reload, does it take effect or do I need to stop and start the Postgres?
If it is a parameter that is changeable at reload time, it will take effect. And the other nice thing about reload is if you actually mess up a parameter, it will simply refuse to change. And you'll get an error message saying, error found in configuration file retaining previous configuration. At least Postgres 9.1 and later, that'll happen. If you're in an earlier version of Postgres, it won't.
And reload will not give any corrections, right?
No. No, it doesn't. And like I said, one of the important things to understand is that some of the things you can change are defaults. Like statement timeout, for example, is a default, actually, that each new connection to Postgres inherits and then can alter. Well, if you change a default, that only affects new sessions that log in after you changed it. So if you're trying to change something in order to affect existing concurrent sessions, a reload won't be sufficient. We actually went through all of this. So let's talk a little bit about PSQL. Yeah? I'll show you that when we get into the configuration file. So we've got, let me show you a little bit about PSQL here. So there are graphical interfaces for Postgres, but what the majority of the Postgres developers use is the command line interface. And for that reason, actually the command line interface is the most full-featured one. On top of which, when you're SSHing into a server that's located in San Antonio, via a VPN and a gateway server, it's almost certain you're not going to get a graphical interface to work under those circumstances. So you need to actually be able to use the command line interface because if you're administering servers, that's what you're going to have to use most of the time. Fortunately, the command line interface has lots of features. Some of the graphical interfaces, by the way, if you're doing development on your own, PGAdmin, available for Windows and Mac, and Linux too. I guess it's available for Linux. I just never use it. Is a nice one, particularly for people who, anybody here cross over from SQL Server? Yeah, because if people are used to the SQL Server thing, it was actually kind of designed around the same look and feel. But let's do the command line interface. So again, here you're going to switch to Postgres. But I'm going to switch over here. So we're going to log into a database, a test database that I actually created for these exercises called libdata. It's a fake lending library database that I did for exercise purposes because I can show off a number of things with it. And so actually PSQL in this. Now, it actually gives us a bunch of feedback. I've actually set up a custom PSQL format, non-default, in order to make stuff look a little bit better. Because among the features of PSQL are a number of formatting features. You actually need to follow along on this, but I don't know what directory I'm in here. And that's actually set up in this PSQL RC file. Again, not something you need to know or do immediately, but if you use PSQL a lot, you discover that you actually use the bash shell a lot, you discover that you actually want to customize the shell. And how you do it is the psql-rc file. But in the meantime, let's actually go over some more basic PSQL functionality. So one of the most basic and most useful pieces of functionality is that PSQL itself has an extensive help system. So if you do \, then what you actually get is a list of all of the special commands that PSQL will take. Which includes lots and lots of stuff, many of which, it'll take you years to actually know what you want. And one of the most useful of the special commands is \h, and \h will take the string that you give it and look it up in the PostgreSQL documentation. So if you can't quite remember the syntax for an SQL command and you don't want to be bothered opening up a web browser and looking in the PostgreSQL documentation that way, you can actually do -h in the command and you can get access to because all the documentation entries are separated into sort of a basic part and extended part, and you get the basic part here. So like, if you just can't remember, like, here's the one I use all the time, create trigger. Because I can never remember whether on goes before for each or whether for each goes first and then on goes second. And so I always end up doing \h for that. So now the other thing that we can actually do is that we use all of these \/ commands to is for browsing objects in the database. So for those of you who missed it, \dt, and that gives you a list of tables in the database. So it's pretty simple. We've got tables. What table, what it is, who's the owner. And if you want to look at details of stuff, \d, and you can add the plus, and the plus gives you a little bit of additional detail. In the case of a table, it shows you dependencies of that table. In the case of a view, it'll show you the definition of the view and that sort of thing. So you can look here, and we've got a lot of bad wraparound, but you'll actually see it a little bit better in your own terminal. And then we got things like what are the indexes on it, and what are the foreign key dependencies, and all of these other things. So that's basically for browsing. So a lot of people get into trouble with this. Like they're looking for, one of the things that people actually get into trouble with is, for anybody here use MySQL a lot? So they cross over to Postgres and they try to use these show commands. And in Postgres, show actually is only for configuration variables. So that'll show the configuration variables. But if I try to do, I get this. And then people are like, wait, what the hell do I do? And unfortunately, because we adopted show as a way of showing configuration variables before MySQL had show table, we couldn't also support their command. Because what if you have a table that has the same name as a configuration variable? What's it going to do, right? So now leave that session open, and we will go back to other stuff. Now, one of the things you actually need to talk about with Postgres is extensions. Extensions are really important because, frankly, for a lot of people, the extensions are the reason why they're using Postgres in the first place rather than another database system. These include things like extra programming languages in the database, like you can actually write triggers and stored procedures in Python or Perl or Ruby or JavaScript or Lua, or a couple of other things. You can, add other stuff. But the thing about extensions is, like optional modules for a programming system, they need to be installed separately. Some of them are available as packages from the PostgreSQL stuff. Like if you want to install PL/Python, there's generally a PostgreSQL-PL/Python package available. If you want to install some of the other things, there's generally a package available. There is a whole bundle of popular extensions called Contrib. And it's actually extensions and tools, but it includes a bunch of extensions that is often available as its own package. Other ones need to be installed by compiling them or installing them from this thing called PGXN, which is a directory, an online directory of extensions. Extensions were handled very differently before Postgres 9.1. So if you care about your Postgres extensions, you really don't want to be on an earlier version. Because basically earlier than this, extensions could only be installed from source. They couldn't be upgraded. There's a whole bunch of other stuff. So you really want to be 9.1 and later. So in the libdata sample database, we have a few extensions already installed. Among them are PGSQL, which is actually installed by default in all Postgres installations. It's our SQL extension procedural language for writing procedures and triggers. The reason why it's listed as an extension is you can't actually remove it. If you have a high security installation, you aren't using any PGSQL in your database, you can actually remove it as an extension for security reasons to prevent a logged in user from creating, say, a recursive function that will use up all the CPU in the system. We've got CI text, which is an optional case insensitive text data type because Postgres based text is case sensitive because it's Unix based. And we have ISN, which does product codes and ISBNs. And because this is a lending library database, I extended that, and that's another optional extra data type. So when you install an extension, the first thing that actually needs to happen is most extensions have a binary file. They have like a shared object C file that needs to be installed to a specific location within Postgres' hierarchy of files so that it can access it. The packages will install this for you. If you actually compile one and you link it into the running version of Postgres, when you compile it, it will write its SOs to the right place. So most of the time you don't actually have to think about where those are. But first you have to install the binary library, and then second you have to install the extension in each database where it's going to be used. Now there are some extensions that are what we call SQL only extensions. They don't have a binary component. A good example of this is PGPartman, which is a partition manager tool to make it easier to manage partition tables. And in that case, there is no binary component. So if you're on Mac or Windows, you're going to be using the Enterprise DB installer or some other external tool to install extensions, mostly because you generally don't have quite the same build environment. So let's actually mess around with extensions too, because that is something, if you're administering Postgres, you're going to be called on to do. So first thing is, let's actually look at what extensions we already have. So that was \dx, if you missed it. And then you can see we have CI text, ISN, PGSQL installed in the libdata database. Now we want to add another extension. So HStore is popular because it does a key value set within an individual field. So it's very popular with developers. It's now being used in a number of things. We had it before we had JSON in Postgres, and so it got used a lot for stuff. And also, if all you're going to be doing is one flat level keys and values, it's a little bit more efficient than JSON for that reason. So well, let's go ahead and create that one. You just do create extension. Now, one of the other things is every one of those / commands is generally a wrapper around a query to other system tables that are available as tables. Now, a lot of them, if you query them as tables, are fairly cryptic, as in it's really hard to actually tell what's in the table because it's got a bunch of ID references and other things. But if you query it as, but some of them are not that cryptic, and one of those is PG extension. So we can actually, rather than using, how about a from clause, huh? So we can actually look at the list of extensions there, and actually, let me show you another thing here. -X switches from landscape to portrait mode in PSQL. So here we can actually see the extensions as the extension table. Now, this is obviously a little bit more cryptic because instead of getting a useful name for the user who owns the extension, is we get a number, 10, which is the OID of that user, which happens to be the Postgres user. By the way, if you want to install extensions, you need to be the super user. You need to have the super user permission. You don't need to own Postgres' files, though. So this is the second class of super user, right? As in, you can actually grant somebody that super user permission. You can say, create user DB admin with super user. And then it will have permission to install extensions. You know, and then we can actually see, and here we've installed the HStore extension. Now, one of the other things you'll notice with the HStore extension is there's a version for the extension specifically. And that is because extensions are released separately from Postgres, they're versioned, and if the extension author has done their job, they are upgradable. But let's actually test that HStore works. So and there you go, we've actually got an HStore value there. Now, let's talk about something else. We're not actually, once again, no hands-on for this because it'd be a little hard to arrange for hands-on, but very important thing for you to know. As an administrator of Postgres, something like, half your duties that do not involve helping developers with pushing stuff, application code, are going to be dealing with updates and upgrades. That's what you got to do, because Postgres is actually pretty reliable on its own, but periodically it has to be updated. And it really has to be updated for important reasons. This actually was sort of our biggest, most important update in recent times from 2013, where we actually, security researchers doing fuzz testing discovered a certain customized string you could pass to psql that would run a single command without authentication. And so this had to be, and we do get these periodically. We don't have that level of, we haven't had that level of security compromise since 2013. And that was one of two that we'd ever had in a 15-year period. But it happens, we release updates on a regular basis, and the updates often have important stuff in them. So first let me explain this issue of major version and minor version. So the major version of Postgres is your first two digits, like 9.4. And this 9.4 requires an upgrade to come from a previous version like 9.2 or 9.2.8 actually, right? It's going to contain new features. There may be some backwards compatibility breakage, so you need to actually test it. And the upgrade process is going to require some kind of downtime in order to upgrade. And sometimes substantial amounts of downtime depending on what your setup is. Then we've got that third digit, which is what's known as a minor version. And those minor versions are basically cumulative patch sets. They're cumulative updates from the original release of that major version. And those minor updates should be applied as soon as you reasonably can with your maintenance schedule. The actual urgency will depend on what's in the update, right? If we send out an update and we say, this needs to be applied immediately because it patches a major data corruption issue that could affect you, then that's a reason to actually stay at work for the weekend and actually get it applied that Saturday. On the other hand, if we say, this is a cumulative update release that contains a bunch of stuff fixed from the last 3 months, then you can just say, okay, well, we have a 5-minute downtime scheduled. 6 weeks from now, we'll apply it then. So these come out about every 2 months. They contain only bug fixes, security hole patches, data loss prevention, minor other things, no new or changed features. Occasionally, I mean, I would say maybe 4 times in the last 10 years, we've had to actually break something in one of these patches. Usually because there was a security hole, and the only way to patch that security hole was to change an API. An example of that was when we had to modify \escapes for quotes. We actually had to change the API for that to patch the security hole. There was no other way. But the vast majority of the time, and so that's out of, I don't know, over that 10-year period, probably 150 update releases. So most of the time the update releases aren't going to change anything that users care about. They are just patching bugs. So you want to apply those as soon as you reasonably can. Expect to apply them all immediately. If you're in a position where you're actually deploying databases for customers to own, then your plan for deploying databases needs to include some kind of a pipeline where the customers can apply the Postgres updates. That needs to be something you take into account in your product design. So here's how you update. Schedule a 5-minute downtime. Download the packages for the new updated version. Shut down PostgreSQL, install those packages, restart PostgreSQL, restart the application. That's it. Again, really 5-minute downtime, often not even 5 minutes. I do actually recommend downloading, if your package manager allows you to, downloading the packages before you shut down Postgres, because that minimizes your downtime window. The way you do that on Red Hat is there's actually an extension to Yum called download only that allows you to actually download stuff before you install them. There's a command for apt-get that's just slipped my mind for a minute, but apt-get that already has that built in. For major upgrades, those come out once a year. So 9.4 will be coming out maybe next month. They have a whole bunch of new features. Occasionally they break stuff that used to work. We try not to do that as much as possible, but sometimes in order to enable new features, we have to break old ones. They require testing with your application to make sure they work, and they require a significant amount of downtime to upgrade. By I mean significant amount of downtime is that here's your alternatives for upgrading. One is what's called dump and reload. And what you do for dump and reload is you use the backup tool pgdump, which we'll go over more later on. So you use the backup tool pgdump, and then you use the backup recovery tool pgrestore to load it onto a new version of the database. For optimum reliability, you install the binaries for the new version alongside the old version and use the new version's pgdump. Because pgdump is always backwards compatible for at least 5 versions, whereas it's not always forwards compatible. It's the most reliable way. It happens to clean up the database in the process. Any sort of bloat or data, garbage collection or whatever that's been pending in the database gets eliminated when you do dump and restore. But this is best really with small databases, because with large databases it can take a really long time. If you've ever done a PG restore of a large database, you know what I'm talking about. It can take hours, days if it's large enough, and if your system is slow enough. So for a larger database, one of the things you might want to consider using is PG Upgrade. PG Upgrade is a tool generally installed in the contrib package for most system package management. And that does an upgrade in place. It's much faster for that reason. It doesn't, however, it doesn't do any database cleanup. And it doesn't work 100% of the time. One thing in particular is for extensions that you've added to Postgres, the extension actually needs a hook for PG Upgrade. And not all extension authors have added those hooks. Now, for the most popular extensions for things like PostGIS and CI text and that sort of thing, those will work with PG Upgrade. But if you've installed something relatively obscure, like there's one for doing queries on GPUs, doing distributed queries on GPUs, they may not actually have PG Upgrade compatibility, in which case you may discover. And in that case, PG Upgrade will exit with an error. It'll say, I found this extension, I can't upgrade the extension, therefore I'm not refusing to upgrade. Yeah?
What exactly does cleanup?
Dump and reload. Oh, the question was, what does cleanup encompass? Yeah. The biggest thing is all of your tables, we'll discuss this in vacuum, have something called bloat, where you have dead space in the table due to rows being deleted or being versioned. When you reload the database, that bloat is all gone because you're reloading it fresh. The indexes will also have bloat, whereas you don't get that with PG Upgrade. There's also things like the transaction counter, and again, I'll talk about that a little bit more later on.
Going back to extensions, that upgrade.
Yeah.
The upgrade page, you delete all the extensions and recreate them?
No.
You said all extensions don't have the compatibility of automatic upgrade.
I said not all extensions are PG Upgrade compatible. And if you have an extension that is not PG Upgrade compatible, that you use, you will not be able to use PG Upgrade unless you want to actually modify the extension to make it compatible with PG Upgrade.
Quick question, if you've got master and slaves, what's the best strategy for upgrading? Do you use slaves or master first?
The question was upgrading if you have a master and slaves. And the answer to that is actually a little bit more complicated. And so I'm not actually going to go over it at this time. If we have a chance, we'll talk about it later. Okay, but one of the reasons why you have to upgrade is after 5 years, we declare end of life for Postgres versions, and the community no longer puts out patches for those versions. So a security hole may be discovered that affects that version, a data corruption issue may be discovered that affects that version, and it won't be patched. Which means that, for example, if you're on 8.4, you really actually need to upgrade already. If you're on 9.0, 9.0 has already had its last patch set, so you better be actually planning an upgrade now. So now there is the issue also of upgrading extensions. So like I said, extensions have their own versions. And so there's actually this command, alter extension whatever update, with an optional parameter of a version number, because you can update to a specific version number. Now that requires you to have installed the files for the new version number, which includes both the binary file if it has a shared object file, and there will be some scripts that are packaged with the extension that are upgrade scripts. And those upgrade scripts, because often things need to happen in the database when you actually update the extension. So this is done separately from any updating Postgres because the versions of the extension are supposed to be separate and independent of the versions of Postgres. Now, if you're jumping several versions of Postgres, this can get complicated because, for example, if you've got PostGIS 1.5 on the system, PostGIS 1.5 stopped being supported in Postgres 9.1. So if you're on 9.0 with PostGIS 9.5, sorry, if you were on like 8.4 with PostGIS 1.5, then you would have to upgrade to 9.0, and then upgrade PostGIS to a 2.x version, and then you could upgrade Postgres the rest of the way, because otherwise you will end up with an incompatibility. And so this generally only comes up if you're skipping like 3 or 4 different Postgres versions. But sometimes extension authors stop supporting old Postgres versions, and so you'll actually have to go through several upgrade stages. Okay, well, yeah, we got enough time to get into configuration here. So we're going to go into configuration. So now, talking about configuration, I actually need to talk about configuration in general, because most people say, oh, my database is slow. Let's change some settings in Postgres.conf and fix it. Problem is that changing settings in Postgres.conf most of the time doesn't do anything. A lot more important, you need to actually look at configuration of the entire system. One of the things about transactional databases is they're good about using every resource the system has, and therefore you need to look at every resource the system has. When you look at hardware, when you look at the operating system, the file system, when you look at Postgres. So I want to look at, this obviously varies by workload, but databases will try to use everything. They'll try to use all your RAM. Postgres will try to use all your RAM. It'll try to use, all of your cores. It'll try to use all of the I/O that you have available, up to certain scalability limits, and we're pushing back those scalability limits all the time. And the important thing, about this is that if you put Postgres in really crappy hardware, right? You've got a really busy Postgres, and you're going to put it on a T2 medium instance on Amazon. Don't expect it to perform well. We don't have some sort of supernatural ability to transcend being on a really slow VM or a really slow server. So you need to actually look at that. The base piece of advice there, the most important first single thing you can do is give Postgres its own server or virtual server. Particularly a bad thing to do is to put Postgres on a machine or a virtual machine that has other database systems on it. Because database systems tend to want the same exact resources from the operating system, and they will fight for them. For that matter, quite a bit of care needs to be taken if you're going to run multiple Postgres instances on the same machine to segregate resources so that you don't end up with a battle for available RAM, for example. So for a cloud server, one of the things to keep in mind is that a cloud server that has a certain spec is going to be substantially slower than a piece of real hardware that has the same spec. So you're going to need to sort of ratchet up, right? Like if it looks like an Amazon M4, extra large has the same spec as the racked hardware you're using, then you probably want an M4 double extra large. The other thing is that on public clouds, just like any time that you're using, say, an iSCSI scan or iSCSI SAN or other remote shared storage, storage latency is very high. And therefore, it becomes a lot more critical to have enough RAM to cache either the whole database or the portions of the database that you use the most frequently in terms of determining your capacity for things. In terms of Linux configuration, there's a lot more detail on how to do these things online. There's a bunch of defaults in Linux that are not necessarily friendly to Postgres. The out-of-memory killer, because of its algorithm, tends to operate on the algorithm of first thing you do is kill Postgres. And for that reason, you actually usually want to disable the out-of-memory killer. There's some good blog posts on how to do that. Just search there. You want to turn off Linux NUMA memory management because it doesn't understand Postgres's memory interaction. Important thing, for the database files, on Linux, you generally want to be using XFS or ext4, or if you're willing to go there with kernel modules, ZFS for Postgres. You do not want to use ext3 for Postgres if you have another choice. ext3 is an elderly file system, and it's really not suited to dealing with today's RAM sizes. And if you are using a version of Postgres before 9.3, you're also going to need to increase some kernel parameters for Postgres' dedicated RAM. Postgres 9.3 and later, you don't care. We've actually worked around that. So now let's actually do an exercise here using tmux and this is just for those of you who are not familiar with tmux. So if tmux has some of these meta commands for going between virtual terminals, and they all start by holding down the control key and pressing the B key. So if you hold down the control key and you press the B key, and then you hit the C key without the control key held down, you'll get a new virtual terminal. And then if you hold down the control key and hit the B key, and then hit the N key without the control held down, you will switch to the other virtual terminal. So make sure you get that set up, because we're about to go into some exercises that require you to switch between two users to do the exercise. And so we actually need the two virtual terminals for that. OK. And why did I want you to look at the xlog directory at this stage? Oh, OK. So that was that. Other configuration for, we've got our FreeBSD person here. ZFS is your best choice on FreeBSD, Solaris variants. Some of these configuration. This is not entirely true, but it is to a large degree true, which is if you have a version of Postgres which is going to be where Postgres' performance constraints are going to be the application's performance constraints, you really don't actually want to be running Postgres on Windows or OS X. I mean, for that matter, you don't want to run OS X on the server, really, period. There's a reason why Apple abandoned their server line. But if, Postgres' performance is going to constrain your whole application performance, then you really want to look to moving to some variation of Unix on the server. Among other things, Windows has a really, really slow file system. And so that affects the speed of pretty much everything you do in Postgres. SQL Server does not use the Windows file system for that reason. It actually has its own file system. So, all right, this is where I want to look at this. So another important consideration when you're actually configuring the operating system and file system for performance is the transaction log, otherwise known as the X log, otherwise known as the WAL, which stands for write-ahead log. In other database systems, if you're familiar with other database systems, you may have heard the term append-only file. Same thing. This is where transactions are recorded. So in order to ensure crash safety, when you commit something in Postgres, it gets written first to the transaction log synchronously, and then it gets synced with the version of the database in memory, which may or may not involve flushing it to disk. By doing that, we can ensure that if there's a crash, when Postgres comes back up, first it will replay the transaction log, and then you will arrive at a consistent version of the database. But this does mean that the write performance to the transaction log for synchronous writes becomes kind of critical for overall write performance to the database system. So if you have a system that's going to have a very high write volume, where you really care about latency on writes, you may want to move that transaction log to its own drive or volume or share or whatever, somewhere it's going to have its own I/O resources. The way that you generally do that is you create whatever volume you have, and then you actually link the PG transaction log directory into there. We don't have a sort of generic command to put the PGXlog directory somewhere else because we couldn't come up with one that would actually sort of support all the variants of how people want to configure this. Now, this advice is actually for certain kinds of storage. I mean, I'll tell you, if you're actually on an array of SSDs, if you're on Fusion, if you're on cloud storage with SSDs, this particular bit is mattering a lot less than it used to. But in general, if you're finding that writes and commits are really slow, look at the transaction log and what kind of storage it's on. So let's actually look at the transaction log. Nope. And you can see here we've got a set of numbered files. These are the individual log segments. Plus there's some information about archiving, which is sort of automated. And that's sort of our transaction log. Also, here's the other important thing. Just because it has the name log in the title doesn't mean that you can willfully delete these files if you run out of disk space. In fact, if you do delete these files, Postgres may refuse to start. If it actually needed those particular log files. And depending on what was in those log files, it may even lead to an unrecoverable database. So don't do that. If you look actually here, they're all 16 megabytes. The log segments are 16 megabytes unless you do a custom compile of Postgres. And they're all just sort of files. You also will get some weird behavior with timestamps on these files because we treat them as a ring buffer. So the numerically highest file will not necessarily be the most recently written to one, just so you know when that appears weird. So PostgreSQL.conf, giant, huge file with hundreds of parameters, of which you care about maybe a dozen to 2 dozen. The vast majority of those configuration parameters are there for 2 reasons. Very specific configuration changes for specific sort of environments and uses of Postgres. Or alternately, there's a lot of configuration stuff that actually has to do with Postgres development. That there are configuration settings in there because we need to be able to set something in order to test Postgres. And they're just there in the configuration file. So for this reason, I don't recommend. So unfortunately, most of the packages for Postgres ship with, by default, the full Postgres configuration file, which includes, all 200 odd parameters laid out in a way that makes more sense historically for the project than it does in any other way. I don't recommend using that file. I actually recommend starting over with your own clean file, because otherwise you're scrolling past screens and screens of settings that you will never touch. And it gets, plus lots of comments, many of which are kind of cryptic. So in this case, I will actually show you an example of that, and this actually shipped with the tutorial, so you're welcome to copy it for yourself. So we're going to look at PostgreSQL.conf here in an editor. Oof, actually I'm not going to use Nano for this because of the stuff on the bottom. There we go. And so I provided one that's more suitable for a beginning Postgres administrator. So we're going to go over the configuration parameters that you're most likely to care about, and then we're going to take a break. And we've got a whole, I have advice on how to set these in here. Listen addresses is one of the first things you change, because usually Postgres ships to be secure, which means it's listening only on local sockets. And you almost always want Postgres shipping on the network. The most common thing to do is to set this to star, which is listen on all network interfaces. Max connections is what's the maximum number of connections we are going to accept from external, users. This is actually a bugaboo in the. This is why I should have started this with -e term. We've got max connections here. I give you some advice on actually setting max connections for various environments. If you need to set max connections to more than like 200 or 300, then you probably need to be using a connection pooler, because the optimum number of connections is actually double the number of cores that you have. That's an optimum maximum. So if you're getting several orders of magnitude above that, then you're not doing very well. Shared buffers is Postgres' dedicated RAM. And that should always be a minority of the amount of memory you have, because we make use of the file system cache as well. Again, I give some sizing advice in this file. Work memory is the soft memory limit for each individual process. It's actually for each individual processes per task. So for things like sorts, creating hash tables, other things that it might do under the hood in the course of a query, is limited by this. And what you're basically telling the backend is, hey, if you need more memory than this to do a sort, do it on disk. And this is a resource limit because it is per process. You think about it, hey, we're going to have 100 concurrent active queries, and if each of those queries is allowed to use half a gigabyte of RAM, then you'd better have 50 gigabytes of RAM available in the system. Now it is a limit, it's not an allocation, so they will only use up to what they need. This is not a performance optimization talk. I'm just going through this briefly. Again, you can actually look at the file for more detailed notes on how to set these things. Maintenance work memory is the memory allocated for doing maintenance tasks. Mostly it means it's the memory allocated for the auto vacuum daemon. I've got some stuff in here, synchronous commit. The only reason why it's in here, it's pretty rare that you're going to want to touch this. This is the default whether or not transactions are synchronously committed to disk, or they're synchronously committed only locally, or what it ties into synchronous replication. The one reason why you'd actually have this in here is if you are running on a public cloud or other high latency storage, and you care more about performance than you do about not losing data, then you can actually disable synchronous commit, and that basically gives you a small sub-second window during which you may lose data, but it will reduce the effect of latency. And that's the only reason why this is in here in a common setting, because so many people are running on AWS these days. Wall buffers, this is just one of those where the default is sort of historical and we don't want to increase it because people are running Postgres on small virtual instances and concurrently and that sort of thing. But for most of you, you're just going to end up setting this up to like say 32. And this is just a small buffer for writes to the transaction log. Checkpoint segments sets the size of the transaction log according to a complicated formula. Most of the time, you pretty much always want to increase this. The default up through Postgres 9.4 is 3, which is a transaction log with a maximum size of like 48 megabytes, which is way too small for almost any modern system. It means that you'll do a lot of cycling the transaction log like in the middle of a transaction because you'll run out of space. And so you almost always want to increase this to something much larger. And much larger depends on how big is your database, how much writing are you doing. You know, for a transactional database, you might be setting this to something like 96 or whatever. If you're doing data warehousing where you're doing these giant batch jobs that write 15 gigabytes of data at once, you may want to set this to something really high, like 256, which I think maps out to 8 gigabytes in size, something like that. But probably pretty much don't want to stick with the default there. Checkpoint completion target. This is one where it depends on what file system you're on. We try to do for a checkpoint is when we flush memory in order to cycle the transaction log. That we say, hey, we need to make sure that everything in memory is on disk so that we know we can get rid of what's in the transaction log before we run out of space. And on a system that is being optimized, we actually try to spread out that memory flush over a period of time so we don't lock up the I/O system. However, if you're on an older file system, such as ext3, or if you're on Windows, or if you're on Mac OS, those file systems don't allow us to do the spread flush. And for that reason, you should disable checkpoint completion target. And on any modern file system, you should enable it. And here's the settings to do that. Auto vacuum on by default. Leave it on unless you are doing data warehousing and you're prepared to manually run your own vacuums and analyzes as part of your ETL procedure. And that's the case where you would want to turn it off. Effective cache size. This is a soft allocation. It just tells the query planner how much memory you have on the system available for caching data. And query planner uses that to plan out queries by determining the probability that the piece of data it wants is already cached in RAM. And this is not an allocation. Again, you're just telling it how much. You generally set this to 3/4 of the RAM on the system if it's a dedicated Postgres server. If it's not a dedicated Postgres server, figure out how much of the system belongs to Postgres. Set it appropriately.
Is that for a process?
No, this is in general. It's per system. Or per Postgres instance if you're running multiple instances on the same machine. Something to think about. So I've got a bunch of settings here for replication. We'll go over these when I actually get into replication. And then there's a bunch of settings in here, some examples of different log configurations. Postgres allows you to log almost everything in the world. And so you end up having these sort of log recipes where you combine different log settings in order to log certain things. And we'll go over that a little bit more later. Also, one of the things you'll notice here is, if you go all the way down to the bottom of the file, because of this separate configuration file, configuration files in a separate directory, Ubuntu requires you to designate where a lot of specific files are because they're not all together in the PG data directory. And so you need to have this in the configuration file if you're going to have these in separate locations. So exit out of that. Now, that's one way to actually look at PostgreSQL configuration. Now let's actually go into PostgreSQL. So go back to your PSQL prompt here. So I mentioned that the show command will actually allow you to see a particular setting. And you can also see all settings. But the problem with show all is it's a freaking lot of scrolling. And because it's a special meta command, you can't actually do filters on it. You can only do show all or show one individual parameter, and that's it. So if you want to actually do other stuff, again, here I'm going to go to landscape format, or portrait format -X here. There's actually a pseudo table, a system catalog that looks like a table, even though it's not really, called PG settings. And I keep forgetting from. And PG settings has a whole bunch of information about a whole bunch of settings. So let's actually get a useful one here. So you can see this actually better on your own terminal because you're not suffering from horrible scrolling. But here we've got, you know, the current name, the current setting, what unit it's in. In this case, it's just binary. It's on/off, so there's no unit. What the general category is, and this will actually match the categories in the default PostgreSQL.conf file. A short description taken from the Postgres docs, or a one-sentence description of it. Remember we talked about reload and restart in different parameters? This is where you can, one of the places where you can find out. So that context equals postmaster, that says this only changes at restart. You know, and then veritype Boolean and that sort of thing. These other things, boot val, reset val, that sort of thing. This actually tells you what the different values are, and then the source file and the source line is if you've changed it in postgres.conf or another file, then it will tell you where it was changed from, which can be important. If you say, hey, I thought I changed that, why is it still set to this other thing? You can actually look in PG settings to find out why it's set to the other thing. Because, for example, Postgres allows you to create a configuration directory instead of just a single configuration file. And if you've got a configuration directory and you've got like 6 different configuration files in it, it's very easy to lose track of where something might be configured. You know, and again, if you look at this here, so for context right here, sighup context means that it can actually be reset with a reload, as does user. So sighup says it can be reset as with a reload of Postgres, and user is anybody can change this on their own individual session command line. If you're interested in more about this sort of configuration, I actually have another tutorial that there's slides up for, which is all about PostgreSQL.conf, and it goes into a lot of this in detail. Let's see, do we have more stuff for configuration here? No, we don't. The nice thing about PG settings, though, by the way, is as a pseudo table, you can actually do things like, so I can do if I want to see all the log settings together, I can do something like that. Yeah, actually, it's so you can apply filters to it and go it. And the other nice thing about this being an SQL query is you can have external monitoring tools that also will query that. Yeah. So the question was about creating users if you're doing authentication with LDAP. And the answer is you create the user inside Postgres. You create the user inside Postgres, but you don't set a password or anything for it. And you define it in pghb.conf as having LDAP authentication. And then you'll have to use your LDAP management utility to create the same user in LDAP. Okay. So please do follow along with that because we're going to actually make use of that bench user later on. And if you haven't set up the PGPass file, it'll be wonky.
Is there a reason the PGPass file is executable?
No. No, you can actually do it 600. That works. So the and now if we actually do we don't get prompted for a password anymore. So okay. So some general tips for security. Number 1, don't expose port 5432 to the internet. Unless you yourself are like a cloud host, where that's going to be your business, you know, you really want to keep port 5432 open only on a constricted network. Because, yeah, we do a lot to make Postgres secure, but we do more to make Postgres performant. And there are some cases where you have to make trade-offs between performance and security. And as a result, if an unlimited number of Ukrainian, Chinese, whatever hackers are going to be allowed to pound away at port 5532, I guarantee you they will eventually find a way in. So don't expose that to the internet. Don't allow regular applications and regular users to connect as the super user. Create a separate application user or separate individual users with restricted permissions. And use the strongest authentication that is practical in your setup, right? So if you actually have access to LDAP authentication or whatever, and you don't care about a few milliseconds of extra latency for the external authentication, then use that because it's more manageable. You can enforce things like password rotation. The passwords are not being stored in plain text anywhere on the database system, and for that reason are more secure. So those are just some general tips. So now let's actually talk a little bit about connection pooling, because I did mention several times that if you're increasing max connections, you're going to want connection pooling. And the truth is, most of you are going to want some form of connection pooling. I mean, actually, we go this. So how many people here are primarily dealing with a web application? Yeah, so all of you are going to want connection pooling of some kind. The only ones who want, how many people are dealing with like data warehousing? Yeah, so you guys may not, probably won't actually care about connection pooling. So the thing is with Postgres, every user connection to Postgres is a process on the database host. And at the realm of several hundred, even if those processes are idle, they start consuming large amounts of resources on the database host. Even if they're idle, yes. Where that starts becoming a real problem often depends on your system resources, what version of Linux on, which version of Postgres we're on. But certainly if you've got 700 connections open on the database host, you're going to be losing a fair amount of throughput to connection overhead, even if only 5 of those connections are active. So for that reason, if you're supporting an application that requires a large number of connections, like any public web application does, you're going to want to use some form of connection pooling. Now, some application frameworks, like J2EE particularly, have connection pools as part of the application framework. So if you're running a J2EE, I recommend use a J2EE connection pool. It's going to understand more about your Java code and what kind of connections it needs than anything external. But if you're running Tomcat, if you're running an interpreted, if you're running an interpreted language like Python or JavaScript or whatever, or something else that doesn't have connection pooling available as a library for the language, you're going to want to use an external connection pool. And the one we're going to go over is the most popular one, PGBouncer. One other warning, by the way, there are a lot of platforms like Tomcat, like Ruby, that claim to have a connection pool. But when they say connection pool, what they really mean is persistent connections. And it's not the same thing. Our concern here is idle application connections should not use up resources on the database server. And you don't get that out of the Ruby connection pool. So if you're using Ruby, you want to be using it with PGBouncer. So now PGBouncer it's a tool released by Skype. It's what's known as an event-based pooler, so it's using libevent to actually poll all of the front ends. It's a completely separate package, and the reason why it's a completely separate utility is in really high performance environments, you actually put PGBouncer on its own server. So the application servers connect to PGBouncer, and PGBouncer connects to one or more database servers. But depending on your configuration, in other environments, you may put it on the application servers. And that's a good environment for if you want low latency on new connections. And you care less about how many connections you're using on the database. You care about new connection latency. On the other hand, if you're trying to make the connections efficient as possible, the least number of connections, then you might want to put it on the database server instead. Or, in some cases, both, because PGBouncers can connect to other PGBouncers. The other thing that we're about to use actually here is PGBench. This is a simple micro benchmark. It doesn't give a good workout. It does a very simple sort of write workload on Postgres based on a database benchmark that was written in 1988, I think, to give you an idea of how simple it is. But it does ship with Postgres, and it does create some write and reload on the database. And so if you're trying to actually test something out, it's useful because you can install it and set it up in a couple of minutes, as opposed to other more rigorous benchmarks. So we're going to go ahead and set up pgbench because we actually want it for what I'm going to show you with pgpool. Postgres ships with some operating system command utilities that replicate commands that are available in SQL. CreateDB is one of them, and CreateDB simply sends create database, the command create database, to the back end. We also have create user, which sends create role to the back end, and a couple of others. The reason why those are there is actually largely historical, because once upon a time those things were not available as SQL commands, and they are now. But in this case, we're just going to use it for simplicity. So CreateDB bench, and that actually creates a bench database, a database named bench. And now we're going to use the pgbench utility as the user bench. So -U bench. And we're going to create a benchmark database of size 10, which is a few thousands of rows. And you get a bunch of feedback when you do that. May take longer or shorter than it just took for me. OK, so now we're going to look at the pgbouncer setup. So switch to the root shell. And we're going to look at the pgbouncer.ini file. So pgbouncer did originate, I think it may have originated on Windows, and for that reason it uses an ini file instead of a .conf. Just so you know, it's a different configuration format. So go ahead and look at, and so we're going to go ahead and look at that one. And basically what pgbouncer does is you define a bunch of database handles. So when somebody connects to pgbouncer, they request a database, because that's the Postgres protocol. But what pgbouncer does is it redefines what the database means, and then you can have a whole what is known as a DSN string, which is a series of parameters and values that define the actual connection. And anything that's available in a Postgres connection can be defined here. And any ones that are not defined here are supposed to be supplied by the client that's trying to connect. So in this case, all we say is if somebody tries to connect to the libdata database, they're going to connect to localhost, and then you pass everything else out. So they're going to connect to libdata as localhost as the user who requested the connection and everything else. You can redefine other stuff, including putting a password in here, which there can be reasons to do. You can connect as a different user. You can connect to a different database. You can redirect it to other servers. That's why it's called pgbouncer. Beyond the other stuff, we're not really going to go into pgbouncer connections in general. You do want to say is we want to define, again, what network interfaces we're listening on and what port we're listening on. So we're listening on port 6432 now, which is often customary for pgbouncer. Now the other thing is, pgbouncer unfortunately does not support all the different kinds of authentication that Postgres supports. It doesn't support SSL currently, some work on that taking place. And it basically only supports either trust authentication or hashed passwords. Or a couple of sort of encrypted passwords according to other encryption schemes. But I don't necessarily recommend crypt or plain as being advantageous over hashed passwords. And so we also need to set up this auth file that has a collection of hashed passwords. So let's take a look at that. And so that just has, oh, those are unhashed passwords. You can also give it unhashed passwords as well. So in this example, we have unhashed passwords. Not necessarily the best setup, but we have the username and the unhashed password. pgbouncer will also accept the username and the hashed password for authentication. And the, is that in here? No. Yeah, no, I don't have that utility installed. Never mind, not going to show that. In which case, those would be, oops. Oh, we lost it. Okay, anyway. Those would be strings beginning with MD5 and be the long hashed string. So, so now let's start up PG Bouncer. Now, one of the important things to know about the user list file is that this is the password to authenticate to PG Bouncer itself. And unless you put a password in the connection string in pgbouncer.ini, it is also the password that PG Bouncer will use to log into Postgres. So in the most common configuration of PG Bouncer, that's going to be the same as the password that you defined on Postgres for that particular user. So go ahead and start up PG Bouncer if you didn't already. Now let's switch again to the Postgres user. Control BN and switch to the Postgres user. And we can now connect to the PG Bouncer port there. And the PG Bouncer port just redirects us to the local instance of Postgres. So quit out of that. So switch into the pgbench subdirectory of the Postgres user's home directory. For those of you in Vagrant, that might actually be there instead, if it's not in the Postgres user's home directory. And if you actually look at this, one of the things that pgbench allows you to do is it allows you to define custom benchmark scripts. So I defined a custom benchmark script here just so you can see PG Bouncer in action. And if you actually look at this, one of the things that you do with PG Bouncer is define the number of connections you want. So the -C here. So we've got 16 connections going in. But the script that I actually wrote has a fair amount of idle time on each connection. So if we actually start it, now switch back to the other shell, because we're running pgbench. And we're actually going to switch to Postgres in that shell as well, because that way we can actually get in. And we can take a look at we're just going to do a count star from pgstat activity here. We're going to get into pgstat activity more later because it's a very useful pseudo table for you to know. But for right now, you should just know that each row in pgstat activity relates to one connection to Postgres. And you see, even though we've started up 16 clients, we're actually only using 4 connections to Postgres. And that's the big thing that PG Bouncer does for you, is it allows you, if you've set it up in pooling mode, it allows you to actually use fewer back-end connections than you have client connections, assuming a lot of those connections are going to be idle. So switch back to the shell, and we're going to terminate. Hit Control-C, and we're going to terminate pgbench. And actually, you don't need to follow along with this, but I'm just going to actually show you something here. I forgot to show you one setting. So there's one other important setting for PG Bouncer. Which is the pool mode. There's actually 3 different pool modes. Pool mode session is every connection to PG Bouncer is a connection to the database backend. And that's really only useful for basically, failing over connections and redirecting them around, because it's not giving you more connections. It's not giving you more client connections than you have database connections. Transaction is what you'd use most of the time. That is, transaction says, wait for the transaction to complete before you release the database connection, and then make that database connection available to other users. Now, if your application was set up to connect directly to Postgres and has never gone through a pooler before, you may need to be careful with this, because, for example, if you set session level variables within Postgres, like you do set time zone inside Postgres, then if you're sharing connections in a pool, that's not going to be persistent. And that can prevent people from switching to transaction mode. Very few people can make, yeah?
And it does not support prepared statements.
So the question was, does PG Bouncer support prepared statements if it's coming in through transaction mode? And the answer is actually yes, but with caveats. So number one, if your prepared statement is not going to be inside a transaction, then you need to be using the very latest version of PG Bouncer. The way that's handled has actually changed very recently. I know because one of my coworkers did the hacking on it. So the second thing is you need to be using anonymous prepared statements rather than named prepared statements, because the problem with named prepared statements is that the names can conflict. So that's still not going to be acceptable for some kinds of Java applications which use name prepared statements and use them much later on. That's still not going to work for transaction pooling. But for most of them, because like Ruby will use prepared statements and Go will use prepared statements, but they're anonymous prepared statements, and those will work with current versions of PG Bouncer. Although we need to, there's a special option for the Go driver, which I'll tell anybody about if they're using Go later on. So anyway, it's something that you need to know about for like public web applications and stuff, but it may require modifications to your application and or driver settings in order to actually switch over. Statement pooling is usable by very few people because it basically means that every statement that you send to the back end is completely independent of everything else, and thus can be pooled independently. Yes?
Going back to what you were saying about, like, for instance, when we set session statement timeout, and when we connect to the database, so that wouldn't persist if you're using transaction. So, like, is there a place to set that up here?
Well, you can set, so the question was whether or not statement timeout would persist. And the answer is no, it wouldn't persist if it was set on an individual session basis. So if you want to do that, then you can handle it a couple ways. One is, if it's going to affect all users, you can set it in PostgreSQL.conf. The second thing is, you can actually set statement timeout in a lot of other settings as a property of the user. So whenever you log in as that user, you inherit that. But if you need to set it dynamically, then you can't use transaction pooling. So, where are we now here? So there's PG Bouncer. Okay, next important thing, very, very important for everybody, one of your most important duties at DBA, yes?
How is PG Bouncer related to PG Pool?
Okay, the question was, how is PG Bouncer related to PG Pool? In my own personal opinion, I don't recommend PG Pool for the vast majority of users. PG Pool historically has suffered from being a bit of a Swiss Army knife, which means it does about 8 different things and it doesn't do any of them well. That's a personal opinion. Obviously, a bunch of people disagree with me and they do use PG Pool for things. One of the things to understand about PG Pool, number one, it does not allow you to pool connections between different sessions. In fact, PG Pool will create a separate session for every database and user you're pooling among. So it actually increases your number of connections rather than decreasing them. And it does allow you to do some nice things about failing over between different database backends, which PG Bouncer does not handle. And that's actually the main reason why people use it. Your big issue is, so what I'm saying in general is that you use it for a completely different purpose. You would use it actually to help automate failover between, say, a master and replica, rather than to, say, lower your connection count or just simply redirect connections to a different server. But do understand that PG Pool is also a very complicated utility because it's got a bunch of extra features like a sort of lightweight multi-master replication and a caching thing and a bunch of other stuff that even if you're not using them make it very complicated to set up. And for that reason, like I'd say, you know, we've got a couple hundred clients. I think only 3 of them are using PG Pool, and there's a good reason for that. So, backups. Another very important, right? If we get through, everybody can connect to the database is running, it's installed, it's updated, and everybody can connect. The next thing we really need to talk about is backups, because if something happens to that machine and you don't have a valid backup, you're in trouble. For example, if you start getting these messages in the log, this is actually, it's a couple years ago, but this was, these were the log messages that somebody sent into a Postgres list, which is how we discovered a particular data corruption bug in Postgres. This data corruption bug caused unrecoverable data corruption, as in whatever data was corrupted cannot ever be retrieved again. So if you've got these kind of messages in the log, it is time to reach for your backups. And if you don't have any backups, it is time to reach for your resume. Unfortunately, this is most people's DR plan these days. We're not going to go into the whole details of planning out a DR plan, but let's at least go over backups. So Postgres has 3 different primary methods of taking backups. Number 1 is pgdump. Number 2 is point-in-time recovery, abbreviated as PITR. And number 3 is file system snapshots. So pgdump, this is what we call logical backup. It backs up the entire database as a series of SQL and bulk load statements. It can be compressed as part of this. You do a pgdump and you compress. And one of the great things about pgdump is it is version agnostic to a degree. And to a degree I say, like, if you create a pgdump file with version 9.3 and then you try to load it on a server that's running version 9.0, it may not load, because it may contain stuff that wasn't supported by 9.0. And over a bunch of versions, like I know if you actually pgdump with 8.0 and you try to load that in 9.4, I believe it doesn't work currently. So if you jump like 8 years of versions, it won't necessarily work. But it's great for small databases. If anybody here is running a database that's like under a gigabyte in size, just use pgdump, don't bother with anything else. Because you can take a pgdump every 10 minutes if you want to. It's not an issue. It won't take very long, right? And pgdumps have a wonderful amount of portability, which makes your backup picture very simple. Unfortunately, the custom binary compressed format is not the default, again, for historical reasons. But it's the one you always want to use. So use -FC, which is that custom binary compressed format, because it's really what you always want. The only reason why you would use the default format is plain text SQL. And the only reason you would do that is, say, if you were dumping a single table and you wanted to take a look at the definition of that table in a file. And that's what that plain text SQL is good for. But otherwise, you always, if you're doing this as part of server backup, you want to use -FC. Now, one of the other things important to understand about pgdump is you are dumping an individual database. You are not dumping the entire system. So if you have several active databases, you'll need to dump them separately. It also doesn't back up system objects, such as users. So the users need to be dumped separately if you want to make them part of your backup picture. Now, the set of users and roles doesn't change all that often, so it's not as much of a concern for most people. But it can be important if you haven't backed them up at all. Now, pgrestore is the utility to load the pgdump. It's got a parallel mode for fast loading, which is important because one of the things when you're restoring it, pgdump doesn't back up the indexes as binary. It just backs up a command saying build an index. And the index building phase is often the slowest part of a restore, and so you want to do that in parallel if you can. You can also use pgrestore to restore only specific objects. And that can be really important. Like, I deleted this one important user from the users table, and I don't want to restore the whole database. I just want to get that one user back. You know? So you restore the users table to an alternate database and just extract that one user. And it gives you a whole bunch of commands and that sort of thing. So let's actually do that. So switch to our Postgres shell here. And make sure you're in your home directory. So we're going to pgdump, custom binary format. -v is just verbose, so we can see what it's doing. not what you'd actually do in production. Dash F is what file am I backing up to? You can actually pipe the output of pgdump to other utilities, etc., if you have some reason to. You don't have to use the dash F switch. And then the required parameter for pgdump is what database am I connecting to. So you do that, and you'll get a whole bunch of output of all the things that you're backing up. For anybody who missed that, well, it's in the instructions. So now we want to actually practice. We'll practice restoring this to an alternate database as an example of something that you might do. So let's go ahead and, well, actually, first, so you can take a look at libdata.dump right here. We've got this. It's 1 megabyte in size. By the way, on typical kinds of data, if you don't have a lot of compressed data in the database, because Postgres supports large compressed data, but if you don't have a lot of compressed data in the database, you generally get somewhere between 10 and 20 to 1 compression on pgdump files. Part of it depends on how much of your data is in indexes versus how much is in base tables. But it's going to be a lot smaller, which is the other reason why pgdumps are nice. And if you actually, PG restore has a dash L switch which just says list everything in there. Now we're not going to get into this, but one of the things you should know is that this actual list is not just an informative list. This is what's known as a manifest. And if you actually save this to a file, you can modify it and give PG restore highly customized instructions on which specific items to restore. In cases where you say, hey, I want to restore everything except this one table. Or I want to restore the tables, but I don't want to restore the primary key constraints because the database is corrupt and they'll fail. Or something else where you want to actually edit the specific items that are being restored. So let's actually, so we're going to create an alternate database, create db libdata2. So again, verbose, you can see what it's doing. So when you're designating the database for PG restore, it's different. You use this dash lowercase d switch. And the reason why you do that is otherwise by default PG restore tries to restore to the database that you took the backup from, because that database name is in the header of the file, right? So use this dash lowercase d switch. I do mention that especially because dash lowercase d, most of the Postgres commands are very consistent. If they have a particular switch, it means the same thing regardless of which command you're using. A few of them are idiosyncratic. Dash lowercase d means a different thing for some different commands. And the required parameter is our dump file, right? So we need a lot of output here. Now in a real production thing where you're restoring a database that's not just 5 megabytes in size, particularly when we get to these stages of creating indexes and creating constraints, creating like key constraints and stuff, those will take a long time. You know, and for that reason, if you're actually PG restoring for something for production, I recommend doing it with verbose, because that way you'll know the difference between, hey, it's still doing something versus, hey, it's hung up and it's not completing. So go ahead and take a look at that. And if we actually look at this, and we've now got a whole database here of libdata2. Now, I'm going to actually give you the second kind of backup and restore, which is point-in-time recovery, because it actually turns out to become a very important thing for a lot of people to do. Let's actually talk about that a little bit. Yeah?
If you use the binary file format, does it skip over large tables if you tell it not to do it, or does it still repeat the entire file?
The question was whether the binary table format skips over large tables. Well, it'll skip over large tables if you tell it not to restore that table.
So it just seeks right past it?
Yeah.
That the rest of the file, like if you were using
Correct. Yeah, so yes, so if you were using the non-binary version, yes, you still have to scan the entire file. Whereas the binary version, it actually has locations where the different things are. Yeah. So PITR backup stands for point-in-time recovery. It's also known as binary and continuous backup. The idea is that you take a snapshot of the database files and then you accumulate copies of Postgres' transaction log. This is your best method of backup for really large databases, where a PG restore would take a prohibitively long time. Like you're restoring an index on a terabyte-sized database, you know, a terabyte-sized table, that can take 7 hours to build, which can be prohibitively long. And it's easily combined with replication. So let me just give you a quick sort of animation of the principles behind point-in-time recovery, because it's hard for people to grasp at first. So the idea of point-in-time recovery is we create an image of the entire set of database files. We create a copy of the entire set of database files. But one of your problems with creating a copy of the entire set of database files is those files are changing while you're copying them, right? So what we have to do while we're copying them is we're also making copies of all of the transaction logs. And the transaction logs will bring us up to date with any inconsistencies between the files from the beginning of the copy to the end of the copy. And then at some point in the future, and then we will continue to save up transaction log files after we're done making the copy until we take our next copy, and then we're going to save up more transaction log files. Now, if somebody actually makes a mistake, point-in-time recovery is your best guard against the most frequent cause of data loss, which is administrator error. Oops, I thought I was on the dev database. And you drop an important table with user data in it. So then you say, OK, well, here's the point in time when I did that. So what I want to do is I actually want to restore to a point in time just before that. Now, a lot of the commands for point-in-time recovery can be somewhat troublesome. There's a lot of little sort of fiddly configuration stuff in it. So don't be surprised if when we do the exercise, you actually get stuck somewhere in the middle. Just try it again on your own. There is a reason why there's a whole group of different tools to actually manage that for you. Barman, which is a really good tool for using on dedicated servers. Wall-E, which is the AWS equivalent for that. It's actually specifically optimized for backing up to S3. OmniTI is this thing called Omni PITR. There's a couple of other sort of archive manager tools out there for Postgres. But we're going to actually use the system level commands, because I always believe in actually knowing what's going on under the hood, because if you know what's going on under the hood, then you can use any tool you want. Whereas if you don't understand what it's doing, then you might be stuck with a tool that doesn't work that well. So, switch to the other shell. If you're still logged in as Postgres in the shell that used to be the root shell, you're going to want to exit out of that, because we were Postgres earlier. If you haven't, you may have already exited out of that. So we are going to edit PostgreSQL.conf. And so what we're going to do here is we're going to uncomment a couple of instructions here for log shipping replication, or for log shipping. Sorry. So here's one of the things. I said this dovetails with replication. So the point-in-time recovery mechanism, which is called archiving, can also be used for replication or for supplementary replication. Because just like you can actually restore a Postgres copy to a different location, you can actually do that continuously and basically replicate it to a different location. But in this case, we are just doing point-in-time recovery backup. So just uncomment those two lines. Now, one of the important things about this is the archive mode directive can only be changed with a restart. But archive command can be changed with a reload. And for this reason, what I generally recommend people do when they first set up Postgres, even if they're not using archiving in general, turn archive mode on, and then set archive command to something that always succeeds, like /bin/true. And so then Postgres will keep executing the archive command and it will always succeed and it won't do anything. But if you want to actually swap in archiving later, you can do it without needing to restart the server. So in this particular case, I actually have set up a custom archive script. And the custom archive script is here. And then the archive script takes a couple of special keywords that Postgres swaps out. #p is the full path to the archive log file, and #f is the file name alone. And not, well, sorry, %f is the file name alone. And you generally need those in the call because whatever script you're calling to do the archiving needs to know what it's archiving. So save that. Now we need to restart. Oh, whoops. I didn't uncomment enough things. So we actually need to uncomment. Where's the replication section? We'd actually uncomment everything in the replication section. We don't actually need to uncomment everything. This is the one thing that we need to uncomment. So Postgres has different amounts of stuff it may write to the transaction log. The default we ship with, and there's some argument about whether this should be the default, is something called minimal, which is just enough for crash recovery. But if you're doing archiving, if you're doing replication, we need to write some extra information to the archive logs. And so you actually turn this up to hot standby. Now go ahead and uncomment these out as well. I mean, we're not going to get to the replication exercise because we're running short on time, and there is a separate replication tutorial at this conference. But so go ahead and save that. What on earth? And now let's actually restart. There we go. Okay, so I did say I have a script. Now, one of the things that you'll find in the Postgres docs is a very simple example using rsync or CP to actually do the archiving. You pretty much never want to do that. You actually want to have a script that can handle certain kinds of common failures with archiving. And in particular, one of the things I like to do is create a script that has a touch file that will disable archiving. Because here's one of the problems with archiving. If you've got archiving turned on, and archiving starts failing for some reason, like say you're archiving to an NFS share and the NFS share becomes unavailable, then Postgres is going to save those transaction logs until it can archive them. Which means that Postgres will run itself out of disk space if nobody pays attention to this problem for long enough. And when Postgres runs completely out of disk space, you're wedged in a way that's hard to undo. And for that reason, I suggest having something in the script, because the advantage of this is you can create a zero-size file in that location, and then archiving, and then the script will start returning true automatically. Anyway, copy the script. You can use it as an example of a sort of simple shell archiving script to run.
Then you lose your ability to recover not running archive logs.
Yes, that's true. On the other hand, if you're out of disk space, you've got bigger problems. So what would happen after that is you would lose your ability to recover, and then you would get the server running again, and you would take a brand new snapshot manually so that you have a clean backup that you can actually run. Okay. So we're going to switch back to being user Postgres here. Go in the pgbench directory. So one of the things we're actually going to do here is we're going to run some workload on Postgres because I want to demonstrate that this actually works as a running thing, as a hot backup. Because you get some, actually in some degree, you get some funny results if there's no data being written. If one of the things you're testing this out on your own, if you've got no data being written to Postgres, sometimes the snapshot command will hang because it's waiting for like 1 byte of data to be written so it can trigger a checkpoint. So let's go ahead and run a workload here so that we actually got some data writing going on. So I thought this would be fun to demonstrate why you would actually want to recover it to a point in time. So let's see what time it is on the server. I've got the containers configured with UTC. So there's our time thing, right? So what we're going to do here is we're going to simulate a, we're going to go ahead and simulate an administrator error, right? So let's drop the table copy history here. Oh, oops. Sorry, I was logged into the wrong database. So go ahead and drop table copy history here. Oops, I thought I was on dev. Oh, crap. OK. Oh. I just realized I did these in the wrong order. Fortunately, we have 2 copies of this database. So ignore your instructions there, because we were supposed to actually take the snapshot first. And I just realized that I actually have a pasto in the instructions. So I'll fix that in the uploaded version of the instructions first. Because we have to take our snapshot first before we can actually do any recovery at a point in time, right? So so the utility for taking snapshot copies most of the time for PITR, there's other methods available, but the simplest one is PG-based backup. And that's the one you should use most of the time. We're not going to go over the other methods. So PG-based backup, -C fast is triggering the checkpoint on the currently running instance. And it's just, otherwise you wait for a regular checkpoint to occur and you can end up waiting for a long time. That's probably actually what you want to do in production because you don't care how long you wait. But for a demo, we don't want it to be hanging for 5 minutes. -P is just show me a progress meter. -D is where's our data directory. Now, unlike PG-dump, PG-based backup does a copy of the entire Postgres instance. So all the databases, all the users, everything. It also means that that copy must be run on the same exact version of Postgres that you took it from. Well, it can probably have a different patch version of Postgres, although be careful of going backwards in minor versions. Because if we've done a data corruption patch specifically for PG-based backup, and then you go backwards, you may be creating data corruption. So we're going to go ahead and do that base backup right there. Oh. What? That's very interesting. Oh. OK. I had a really severe pasto here. So switch to the root shell. This is not in the instructions, unfortunately, because apparently I got really messed up here. You know what? I'm going to demonstrate the rest of this, but don't try to follow along, because I got some severe pastos in the instructions, and you're going to have trouble following along. Because I actually needed to enable replication connections here. Because PG-based backup uses a replication connection in order to make a copy of the database. So I enabled replication connections, and now I should be able to take a PG-based backup. OK. OK, so now we have our base backup. So let's connect to libdata 2. Let's look at what time it is here, because we need to actually restore to a little bit before, right? Oh, hold on a minute. Need some workload here. OK. So now, if we actually look, so unlike what I would do in production, I'm actually just copying to a local directory called wall archive for the archiving. If we actually look at wall archive, we've got a bunch of files here. First of all, we've got copies of all of the transaction log files, and this will continue to accumulate. By the way, this means that if you're archiving to a wall archive that's shared among several like backup systems and that sort of thing, you do have to have some plan for eventually deleting some of these. And then we've actually got these special files that are .backup. And the special .backup files are basically bookmarks. This shows where did I take that PG-based backup, right? And that file actually tells Postgres where the PG-based backup file is. Okay. So okay, and now we are going to switch to the replica directory. So here we have what we've created with our PG-based backup, which is just a snapshot of the whole, sort of Postgres file system here, right? Now, in this particular case, I'm going to need to actually configure a few things before I try to do a point-in-time restore to this. So one of those is I need to change the port for Postgres because we're running another Postgres instance already here and it needs a different port. But the more interesting part is this recovery.conf file. So this recovery.conf file says when we're recovering Postgres, what to do. So one of these here, this very cryptic command says if Postgres needs to, if we've restarted and reloaded Postgres several times, just continue to follow it. That's not really important, except that you're pretty much always going to be setting it that way. The more important things here are restore command, and restore command says, okay, I'm going to need log copies. How do I get those log copies, right? And a couple of other commands, because we're doing point-in-time recovery here, which is recovery target time and pause at recovery target, right? So for recovery target time, we're doing point-in-time recovery, right? So we're going to give it a time. And pause at recovery target says is when we reach that time, what should we do? When we reach that time, should we freeze without coming up as a standalone, as a writable node? Or should we go ahead and come up as a writable node? Most of the time when you're actually trying to restore something because it's been deleted or whatever, you're going to want to pause, because if you don't come up as a standalone node, what you can do is you can do this thing where you keep moving forward, right? Let's restore it to 3 hours ago. OK, now let's restore it to 2.5 hours ago. Now let's restore it to 2 hours and 15 minutes ago, which you can do that as long as you haven't come up as a writable node. But once you come up as a writable node, you can't do that. So we've gone ahead and we've started up this Postgres instance, and it will now be recovering logs. Okay, so one of the annoying things about the archiving system is it tends to actually produce a lot of kind of spurious error messages. So like these cannot stat messages here, it's actually just telling us that it ran out of transaction log files. And it's looking for the next one, but it can't copy the next one because the next one doesn't exist yet. Oh, damn it, I forgot to set the time. OK, we're not doing this again. We're going to move on to the next one. I'm sorry, so the point-in-time recovery exercise was just added to this tutorial for this particular conference. And so I haven't really hammered it out as much as I would like to. And so we're going to go on to the next exercise because we're running out of time and I don't want to redo it. Actually, woof. We're almost out of time, aren't we?
Yeah, we might want to move to questions.
Yeah. Well, I wanted to actually go into query management, but it's not going to happen. Yeah, sorry. Normally I do this for 3 hours, and I hadn't actually realized until I took the conference schedule yesterday that this was 3 hours minus a break. So it's like half an hour shorter than I'm used to having this for. So I'm afraid we're going to have to move on to questions at this point in order to finish up on time, because this is the morning thing, and a lot of you have to get to lunch and you have to get to the next tutorial. You're welcome to follow along on the rest of the tutorial, which is available via GitHub. Yeah. So questions? Yes?
I realize this is kind of related to wall streaming, but in 9.4, if you were to have a clustered system and already enabling the wall archiving, and are there any downsides to utilizing the archive command with, say, some kind of script that wraps rsync or CP or SCP? Is there a performance issue in trying to get both streaming wall archives and at the same time PITR? Or is that more of a question for the
Yes, so the question was about streaming wall archive, combining archiving with replication, and whether there was a performance penalty. There isn't really overall. I mean, it's like I said, you often combine them with replication for that reason. Specific details about how you do that, you should take to the replication tutorial that follows this one. More questions?
So in like a Ruby environment, when they've set up like 100 persistent connections, if that's getting filed from PG Bouncer, will then those 100 get filed between the number of connections that PG Bouncer has?
Yeah, so the question was, if you've got like 100 persistent connections from Ruby and it's hitting PG Bouncer, whether or not those will get cycled. And the answer is yes. I mean, what PG Bouncer cycles out is idle connections. So it's a question of how much of the time those connections are idle. I mean, obviously, if somebody's done a really good job of Ruby programming, then those connections are idle very little of the time. And so your reduction in the number of connections will be very small. Whereas if it's your typical application, I've seen 10 for 1.
They could be running a select one to see if the connection is still available in that.
Yeah. So the question was, yes. And one of the things I often end up doing with some of these configurations is removing the select one polling that a lot of poolers, et cetera, will do. Is you actually disable that kind of polling because, yeah, because the select one polling will keep connections alive even though the application's not using them for anything. Most of the time what I do with Ruby specifically is I tell people to disable the Ruby connection pool because it's not actually very useful. Because it can only basically share connections that are together on a single thread or single process, and it doesn't even do that very well. And so for customers who have Ruby applications, what I advise them to do is disable all that stuff in Ruby, use PG Bouncer instead. Other questions?
Does PG Bouncer support the automatic failover?
Say that again?
Master to slave?
Does PG Bouncer support master to slave what?
Like automatic failover.
Automatic failover?
Yeah. So if there is an application.
Yeah, it does not. PG Bouncer does not have any automatic failover things. The general way to handle failover if you're doing PG Bouncer is you actually push a change to the configuration of PG Bouncer and reload it. And so there are some automated failover scripts that will do that if PG Bouncer is part of the automatic failover system. But if you're actually looking for a simple tool for automated failover, I recommend HA proxy instead. Because a Postgres connection is just a TCP connection, and HA proxy can fail that over fine.
Do you have any tips for how to sort of tune the size of the PG Bouncer connection pool? So like when you're rolling out PG Bouncer, and you have to start off with some number, would you just set it to the number of connections that were already persisted, and then how would you choose to like?
Yeah. So the question was about tuning the size of the PG bouncer connection pool. The defaults are often pretty good to start out, and then see if you start running out of things. So I mean, one of the things you can do is that you can actually go into your present Postgres database, check pgstat activity, and see how many connections are active and how many are idle. And then set the PG bouncer, the pool size, to say 3 times what your current number of active connections are. And start that way. And if that's within the sort of limits of PG bouncer, which normally starts out with, I think, 20 per pool, it may be completely adequate. Anything else? OK, we need to break for lunch. So thanks a lot. And I'm sorry I didn't get to everything.